Ever wondered how we know if an AI is actually smart? Like really smart. Because let's be honest, a lot of the time, these models can sound convincing but struggle with real challenges. Today, we're diving into the latest research on how scientists are pushing the boundaries of AI evaluation, turning the spotlight on everything from math puzzles to medical diagnoses. Back in our last video, we talked about something called the discrimination index in testing, how some questions are better than others at separating the knowledgeable from the guessers. Well, this research takes that idea further. Imagine building a web of tests that don't just measure what an AI knows, but how it thinks. That's what these new benchmarks are all about. Take the math dataset, for example. It's not just about solving equations. It's about reasoning through complex problems, like figuring out how to calculate the trajectory of a rocket or decoding a cryptic puzzle. And then there's SuperGPQA, which stretches AI evaluation across 285 graduate disciplines. Think of it as the ultimate academic challenge. Can an AI ace a physics exam and a philosophy seminar? But here's the twist. These tests aren't just about raw knowledge. They're about adaptability. Researchers are designing tasks that mimic real-world chaos, like diagnosing a patient with incomplete symptoms or predicting stock market trends based on fragmented data. It's like putting an AI in a lab coat and asking it to solve problems without a textbook. How do they measure progress? They use something called item response theory, IRT, which tracks how AI performance evolves over time. Imagine a fitness tracker for intelligence. Instead of a static score, it shows growth, like watching a plant sprout and grow stronger. By analyzing how models like GPT-4 or Gemini tackle these challenges, scientists can spot where AI excels and where it still needs to grow. The results are fascinating. Some AIs crush math problems, but stumble on ethical dilemmas. Others ace philosophy quizzes, but can't troubleshoot a broken printer. It's like a superhero with a superpower, but no idea how to use it in the real world. But here's the good news. These benchmarks are pushing AI to become more versatile, not just smarter, but smarter in the right ways. So why does this matter? Because the future of AI isn't just about building machines that can talk or code. It's about creating systems that can think, adapt, and solve problems as humans do, messy, complex, and full of surprises. As these evaluations evolve, they'll help us build AI that's not just impressive, but truly useful. What do you think? Would you trust an AI to solve a real-world problem, or do you think it's still stuck in the lab? Let me know in the comments. Next up, we'll explore how AI is changing the game in healthcare. Stay curious. But here's the next question. How does AI actually learn to solve these problems in the first place? It's not just about feeding it data. It's about training it to reason, adapt, and improve. Let's break down the cutting-edge techniques making this possible. Scientists are moving beyond static tests and focusing on dynamic learning. Take DeepSeek R1, for instance. This AI uses reinforcement learning, a method where the model learns by trial and error, much like training a dog with treats. Every correct decision earns a reward, while mistakes trigger adjustments. The result? AI that doesn't just memorize answers but reasons through problems, like a human would. But how do we know if these methods work? Researchers have created rigorous benchmarks to push AI to its limits. There's METR, which evaluates multi-step reasoning, like planning a trip or debugging code. It's the difference between a model that can write a poem and one that can fix your car. Then there's Mind2Web, where AI becomes a web surfing assistant, navigating real websites to find answers independently. It's like giving a robot a browser and seeing if it can hunt down the truth without cheating. But here's the catch. Even the smartest AI has blind spots. A study on medical AI showed that while it can follow rules, it still struggles with tricky, real-world patient cases. And let's not forget the hallucination problem, when AI fabricates facts like they're real. That's why benchmarks like Live Code Bench are critical. They test if AI can write code without faking it, ensuring it's learning the right way, not just mimicking. So what's next? Researchers are racing to build smarter, more reliable AI by creating tougher tests and better training methods. It's like an ultimate challenge. Can your AI beat this? But the real question is, how will these advances change the future of work, healthcare, and even creativity? And here's a kicker. These same techniques are being used to train AI for tasks like hiring and marketing. Imagine an AI that can analyze job postings, find the perfect candidates, or spot the right social media influencers for a product. The line between human and machine is blurring, and the implications are massive. The journey to truly intelligent AI is just beginning. By combining rigorous evaluation with innovative learning methods, we're not just building better models, we're redefining what it means to think. What do you think the future holds? Let's keep exploring together. Stay curious.